This is a short webinar series and a short webinar, 30 minutes. We're going to be looking at use cases, specifically trying to uncover the business value in unstructured content. It's a webinar series put together by both SmartLogic, software company specializing in content intelligence, and KnowledgeEnt, a strategic information management consulting company. So to introduce the two speakers, firstly I'd like to introduce you to Christine Connors, who's Senior Consultant at KnowledgeEnt. Christine has an extensive career in information management. She knows a lot about ontologies and taxonomies and metadata design and development. Before joining KnowledgeEnt, she was the Global Director for Semantic Technologies at Dow Jones. Before that, she was the metadata architect at Raytheon Company. My name is Jeremy Bentley. I am the CEO and founder of SmartLogic. And we started SmartLogic on the basis that organizations can outperform others if they can harness the huge business value contained in content. And actually, if you think about what that means, is we know you must understand the content, we know you have to understand the information and knowledge it contains, and then also how it can be applied to the context of business operations. And so the software that we produce focuses on creating that value from content, and we call that idea content intelligence. And so before Christine takes us through the use case, which is the majority of the time, I was going to do a quick overview of what we mean by that and why we think it's important. And to help that, I've gone back to the 1950s, really to look at how information management was then, and I think we'll find that it's not so different now. But there's been a big change in the last, very short period, and you'll see that change is driving all sorts of problems and new solutions and new thought that's required, and that's really the focus of this. So if we start looking at this picture, this is 1950s information management, and that's what used to happen. You used to have manual tagging of documents in order that they could be filed properly. This is content management, where of course the information was physical and on paper, but then stored in cabinets. And of course, once one had too many of those, one had to find a way to abstract a sort of higher order. And index management was an important element of information management back then. If we then move on to the next part of the process, is when we need to find that information, then we execute it off a search, and here we see a picture of people searching for information, and lastly distribution, when physically it was put in boxes and packed up and sent out. Of course, we could argue that content is very different then, but content, when we think about it, is purely a container of the information and the value of that information. And of course, content comes in many forms. It can be streams of data, it can be ancient scanned images, and variety in between. And today's content universe, of course, is different from the one of the 1950s, but from Word, and it's electronic. But unlocking that content value is still a very hard task. If we look at what that content is, what the information is in that content, we see the minutes that make up the meetings, we see the analysis and the research, the comment, the approvals, the justifications. So this is the lifeblood of any organization, and it is this information that we wish to harness and to put to work, and if we can do that, it's for economic value. And I think it's quite important to ask what is still the same and what is different, because in what is still the same is, well, those types of information. We haven't invented new types. So by that I mean the minutes and the reports and the justifications, that's still the same. Interestingly, I think for most organizations, the process of tagging, managing, indexing, searching, and distribution is at least at a high level, at this level, it's the same. And I think what's most pointed is that there's still a full reliance on manual tagging. And if we look at that in detail, we'll see that when we look at the differences, that actually there's a reason why that reliance is a weak point, is a point of break from the changes. So when we look at what is different, and we'll look at these in a little bit more detail now, we see, well, the technology is different, of course, and I'll go into that a bit more. We're no longer dealing with cardboard boxes and ladders and card index systems. We're dealing with content management systems and information and search engines and portals. The variety of formats, of course, is very different. The volume of data and content is exponentially different, as is the velocity. Of course, using these V's importantly, because it's introducing the big data ideas that organizations are having to deal with, whether they're having to deal with it consciously or unconsciously. That depends. So let's look at each one in turn. Of course, today we have, if you like, the two layers, the human interface and the content interface, content services. And humans have to use portals and business applications to access search engines whose job it is to index and try and provide a way to get to access of the information that's stored in many different content stores, both maybe feeds, but possibly records management systems, maybe information that's not even within the enterprise that you work for, is in somebody else's, it's out of your control. So we've got many search engines, many content management systems, many information feeds, many types of user using many different portals, driving many different applications. And we see that when one gets 20,000 results from a search engine, we see that human beings can't possibly deal with that kind of number. When we're asking a question, we can possibly deal with 3 or 4, the top page of a web search anymore, and we get human overload, let alone information overload. So just to help to visualize what's been going on in the volume stage, this is the submission that Bill Clinton made at the end of his 8-year term to the National Archives after he finished being president of the US. It's 4 terabytes. Don't really worry about the 4 terabytes. What's interesting is what comes next, because the same job run by the next incumbent, George Bush Jr., 8 years, and we see what was the submission to the National Archives at the end of his term. And we see an 80 terabyte, 20 times increase in information volume. And this is hopefully a way just to visualize exactly what's going on inside every enterprise, every organization, every government agency. This 20 times increase in information volume. Anyone who's in engineering will know that systems are built to a spec. 20 times increase in that spec usually puts them out of spec. And it's really that point that I wanted to just introduce, which is that the systems that were built to handle the volumes of only 8 years ago are out of spec. If we look at the velocity, I think velocity, which is, basically it means real-time information requiring real-time processes. We now receive customer feedback in real time. We have to provide security management in real time. We have a massive amount of information coming into our organizations in real time, and that requires a real-time process. If we add the two together, and I think it's quite consciously, we get to flow. So if we've got a lot of content coming in at huge volume and very fast, we've got a big information flow. And that's really what sets aside the organizations which can make an advantage or are going to lose and perish from not being able to take that advantage. Because it's the flow that drives the economic difference, the competitive advantage, the efficiencies, the customer contentment, and on. And it's really those new relationships that you can find in the new flow that gives new opportunities. And if we start to come into information management and things, ontologies, which are an organizing structure of a domain, are very useful for identifying and if you like, capturing those new relationships, and that's what helps drive the new opportunities. So what we see is that if you like, the old traditional status quo of the content of information management from the 1950s until just about today has been fine, but it's no longer relevant. The systems are out of spec, and we need an enrichment process for today's new requirements. And so to that technical layer infrastructure, we add another layer, and it's that layer which we call content intelligence. Now we've been putting this three webinar series together, and last time we looked at the linked data. Next time, the third one, we're going to look at sort of microtargeting distribution. But the one that we're interested in today is the knowledge acquisition and reuse, and specifically how we uncover meaningful similarities in research data. Right? And it's that Christine is going to take us through.
Great, thank you very much, Jeremy.
I'm just going to switch over now.
Okay. I am now going to show my screen. Bear with me for just a moment, please. And I should now be showing the next screen. So, as Jeremy indicated, we're going to talk about how we use the Content Intelligence platform to identify new opportunities for research data, how we can make that data work harder for us. And I'm going to take a moment to briefly introduce the acknowledgement perspective on this task. So this is a slide that we used to talk about, what's the point of digging into all of this legacy data. So for many years, humans have been working tirelessly to make machines more intelligent. And as artificial as that may be, that effort has not been wasted. And we are now reaping the benefits of technologies such as the Smart Logic platform that can make us more efficient and guide us to new insights. And that's what this use case that I'm going to describe is about, is finding new insights. We've designed ways of modeling and encoding the way we think about our environment, our work, and our needs, and in parallel have developed the methodologies that can be enabled and processed by our machines. We've painstakingly developed architectures and database designs for defining our information assets, our business processes, our technologies, and how to analyze our work products to gain new insights. The touch point between the human-centered approach and the machine-centered approach is what we call the lens of meaning. We take information from the machines and combine it with the knowledge of the people using the machines to create meaningful insights and actionable intelligence. Sorry, I'm waiting for a really big, oh, I didn't realize there was a build here. I apologize. Let me get to that. So, one of the examples of how similarity searching, which is what I'm going to be showing you, similarity in information, is Google. Now you're all, I'm sure, familiar with Google and how they run their business and how they run their search capabilities. And that's one of the things that we wanted to tap into in this platform. So they are really trying to assess similarity. The PageRank algorithm, while growing increasingly more complex, has at its heart an evaluation of the similarity between the user search terms and the pages the engines will recommend that they want to review. So you enter your keywords, Google analyzes the rank and the criteria, they evaluate the web pages, and then they suggest links, and you have to choose which ones to follow, and you have to follow them yourself and assess which ones are good. Well, we want to use that similarity capability, but we want to take it to the next step. And another way that we've done that in terms of all of that modeling work that I referenced earlier is Pandora, another service that I'm sure many of you are familiar with. So continuing to set the stage on some of the way that we thought about this particular problem that I'm going to describe of similarity research is that Pandora took a different approach to finding similar things, similar music to what you are currently listening to and liking. They had a much more traditional approach, akin to what librarians use to classify and catalog books and such. Professional musicians were originally engaged to classify each song according to criteria and facets such as rhythm, form, genre, composer, lyricist, singer, and musician, and more. The Music Genome Project provides the taxonomy used for this classification approach, now managed by a team of highly trained musicologists. Over 450 characteristics are captured in a database, providing a really rich ontology of music that is used to help you find more of the kind of music you like. So we wanted to combine that algorithmic similarity approach with a more standard classification approach in terms of how we analyze content and look for things that are similar. And so what we did is we created a tool that allows us to do similarity search for research. That lens of meaning gains accuracy by keeping things as simple, as compartmentalized as possible. This allows it to provide focus for a wider variety of user and application needs. We have decoupled the components of the architecture, which I will show you in a slide or two, to focus on best-of-breed solutions that can be combined in ad hoc ways to drive satisfaction and innovation. The first step is to connect. We build on the foundation of our structured and unstructured content stores. We identify optimal means for accessing those asset repositories in a manner that can be used and reused by all the components in the platform. Next, we use semantic technologies to process the content. Entities are identified, they are annotated and extracted for use in faceted search, in network analysis, aboutness identification, and occurrence tagging, and more. Advanced NLP algorithms are used to detect patterns, parts of speech, proximity, and language, which will be used as inputs to context identification, expansion of search terms, and, quote, meaning determinations. All is stored for use in conjunction with the larger index and aligned to conceptual models created for common organizational user application-specific models. I'm going to go ahead and move on to that diagram. This is where we begin to see how this is all put together. We have our external data sources on our left, and our in this particular case, information from Wikipedia, PubChem, the FDA, and other government sites, as well as internal data sources that are unstructured data sources, that are relational repositories, that are XML stores, and we push them all into the engine that is doing all of this work that I'm describing. And then all of that NLP and ontology work is used as part of a larger index and aligned to these models. Then we get ready for the query processing component to drive the required search applications, and those are keyword search, faceted search, categorization, browsing. We can take the outputs of the queries to deliver even greater value by integrating advanced analytics, visualization tools, model annotation, and ad hoc processing, whatever requirements are to be had. And really that ad hoc capability is very critical. We want to enable new visualizations and new analytical tools to be designed and completed within a day. We don't want to have to go through a really long process to allow a business analyst to examine the information in the way he or she would like to have. This latest project provided a similarity tool, as I've indicated, visualizing the similarity between objects as a dendrogram, which I will show you on the next slide. We kind of see it I'm sorry, that graphic is a little bit light. I will see about darkening that a bit more for later on when the slides are available. But if you can see there, just to the right of navigation facets, there is in fact a dendrogram which indicates the items in this search result that are more similar. And so these visualization capabilities are really useful in terms of helping research scientists, in this case in a pharmaceutical context, identify like objects that they want to examine further as part of their research. This entire tool suite provides a much more granular, more like this capability, returning results that are more precise, rather than simply increasing the recall, increasing the number of results, which is much more useful for the researcher and a much more efficient use of his or her time. As I mentioned earlier, this tool that we have created here at KnowledgeEnt is based on searching for chemical compounds. We use a combination of descriptors extracted from structured and unstructured data sources and mapped to purpose-built ontology to identify compounds that are similar to the original search entry based on the spatial arrangement of functional groups. We identify which features exist in each molecule and index, and then calculate similarity to other molecules based on the likeness and differences of these features. And so I'll show you another architecture, but basically what we wanted to say is, you know, aspirin is very similar to salicylic acid, And we can see that more easily in that visualization. But what we've had the machine do is use the textual description to help us complete that processing with a higher accuracy. So, and as promised, a more technical version of that architecture I showed 2 slides back. And again, what we have here is we have our structured and unstructured feeds of data, or data sources, which are things like SharePoint databases, file shares, the intranet, and intranet sources if desired, and our ontology management systems. In this case, we used SmartLogic for the model creation, and we originally started working with Gate, which is an open source tool, but which has some very precise capabilities. We ended up actually pulling back a little bit on the Gate and using SmartLogic's own internal classification server to do a lot of our NLP work. It was just a much more natural workflow. And so what we did is we pushed those conceptual models and the rules we were able to create in the Semaphore platform in an ingestion workflow that did everything from tokenizing and semantic processing, and then we had some of the Gate work in terms of part-of-speech tagging and whatnot integrated. And we pushed all of that information into our index. As you can see here, we used Solr. And then we used the query processing tools in Solr. And in some cases, we pushed out some of the outputs to R for analytical processing. And in other cases, we pushed it into a search interface. And we used a number of visualization packages. Again, SmartLogic has created a number of really fabulous widgets that we used. We also included some tools from Blacklight and the D3 library, so including that dendrogram. And that allowed us to create a user interface for the search engine results pages that were truly focused on the needs of this particular community. And it also allows us to change out those interfaces for other communities pretty quickly with low effort. And then we also made all of that data available to other search services that may wish to use them. Our approach has an ontology at the center. The delivering and harvesting information as it is indexed to provide more accurate results. So we seeded the ontology with information from internal to the organization, from publicly available ontologies, things such as MESH, for example, in this particular use case that I've just shown for molecular similarity. Not just MESH, but other more deeper chemical ontologies. And then we use the information that is extracted in the platform to push more information back into that ontology and make it richer. So we both capture and annotate, when capture is not possible, the data sources that we are processing, those structured and unstructured data feeds. And then those are used in query answering and analytics. The ontology that we are constantly building and feeding can be used by as few or as many applications as require it inside or outside of the semantic search tool across the enterprise. This ontology serves to harmonize the meaning of entities occurring in disparate data warehouses and differentiate homonyms in a manner that can be natively integrated with the enterprise infrastructure. So it helps create that common language across the enterprise. It allows us to be innovative in our capabilities and provide more precise data from our graph store for targeted analytics. It is a foundational layer for truly data-driven applications. The standard semantic approach can be mainstreamed across the enterprise ecosystem, giving a performance boost to existing technologies and teasing out nuggets of data gold that can be critical components of successful ventures. So we can see it integrating with legacy warehouses, with navigation systems, with specific custom applications, with other metadata management tools, semantic traceability capabilities that you may want to have around your organization. And so you can have a variety of data science applications and innovation supporters. It can be a foundational layer for that common language, that data dictionary. But it also can help bring, because of its ability to integrate with a wider variety of data sources and tools, because it's using standard formats, it can help mainstream those analytics, those operations. And then, honestly, it helps you, as we've indicated here with the similarity search, it helps you put different things together. So there's a we heard an interesting quote at an IT conference in the life sciences realm from the CIO of one of the big pharmas that said, "We've discovered the cure for cancer, we just can't find it." And it was his genuine belief that that his organization had done all of the research that they needed to do to begin to find a cure for cancer. It was so distributed across the organization, they hadn't yet been able to collect those puzzle pieces into one place and put them together into that picture that they needed to move on with some significant impacts on human welfare. And so that is why we built this platform. And so we've tested this approach to similarity searching in a variety of business use cases. Molecular similarity, as I've shown, project similarity, to ensure the right hand knows what the left hand is doing. Lessons learned and best practices can be shared and resources can be leveraged. We've also done it, looked at it with employee similarity. We can't clone our best employees, but we can identify others with similar experiences, knowledge, and potential. Pathway similarity, another life sciences use case, the Canadian Research and Development. And then in the financial services realm, we can identify accounts that ought to be examined for fraudulent behaviors across all industries. We can see things in the human resources area for candidates. And so that, that is the use case and the platform that we want to show you today. And I'm going to hand it back to Jeremy now for some wrap-up and then for some questions that have come up, and then to introduce the next session in which we'll dig into one of those other industry use cases. So, Jeremy.
Thank you, Christine. I need to show my screen. So just to wrap up, we've got a couple of minutes left before the bottom of the hour. As we've been presenting, a number of people have been asking us questions, and I don't think we'll get through all of the questions that have been asked, so we will forward those to everyone who attended as a written response, so everyone will get the answers to all the questions. But we do have a couple, and the first one that has been asked is that you've mentioned, Christine, in your presentation, you mentioned both ontologies and rule bases, and it says, can you have ontology management and rule bases that work in the same system?
Yes, that's a good catch because I only mentioned that really briefly since we're trying to keep this a short webinar. So yes, you can have ontologies and rule bases in the same structure, and I actually am seeing the beginnings of that migration, a path towards really integrating those much more fully, rather than having ontology in one system and a rule base in a BPMN or some other sort of rule system. What it does is it allows, because in a semantic system you can define custom relationship types, it makes it much easier to integrate all of that data into one place. It provides better precision and recall for search results from one core ontology that can then be shared across the enterprise. And then also localized for more specific applications. And so you can do it. I think it is where the future is going, and not for nothing, but the Smart Logic platform really enables that. I don't know if, Jeremy, if you want to add anything from the platform perspective.
I can. I think, if at a very high level, I think ontologies are a very good container for documenting the domain, a set of business processes, or a knowledge base, or a specific subject, or anything, topics, and they're extremely sound at documenting both the topic and the related topics that relate to each other and how they're related. So they're a very good knowledge engine, if you like. And most people in the theory of text analytics will say yes, rule-based classification is the most accurate, but you've got to spend the cost of writing the rules, and that was really one of the founding, if you like, it's the secret sauce of Smart Logic, because we figured out how to do rule-based classification without the economic cost of writing the rules, because they're generated automatically from the ontology. So you've got a good system to capture, if you like, your text analytics and classification standards, and then you can automatically put that to work by applying it to content without the cost, and that's what we did. So I think we're just coming up to the end. We don't have time for any more questions. We do have this quick wrap up. Hopefully you've heard very briefly. It's not really meant to be more than a quick glimpse across how we unlock the value from unstructured content, how we can bring both semi-structured and unstructured content in and combine it with structured data. So if one has, one needs to bring in, for example, the facts that are contained in the written reports in a trial, and you need to bring that in and combine it with some analytical data. This helps do that. Content intelligence does that. And I think you've seen how the use case where we join data from many data sources, and those data sources are both external, so outside of the control of the enterprise trying to implement this system, and internal. And of course, what one can be certain is they're very heterogeneous and very mixed in their quality, and it's also applying that additional quality to the content in order to turn it into a useful, valuable asset. And maybe just perhaps you'd let me point out that we have a third use case. It's the third seminar, which is the wealth management, and it's about obtaining precision client insights from content, from the profiles. So it's a combination of understanding who your user is and what their portfolios are, and how you get insights between joining together all this content in that way. And that will be on September the 12th. So I appreciate everybody who's joined and given us your half hour of your time. And I'd like to thank you very much.